astronomers may have found a new type of object in the Orion Nebula. Serpens is a famous stellar nursery. What if I told you that the James Webb Telescope just found something in space that shouldn't exist? And not just one or two, but multiple structures like that. 6 massive galaxies were recently discovered by NASA using data released from the James Webb Space Telescope. Scientists are confused because they might just need to rewrite the textbooks. Let's take a look at what they have discovered. Number 1. Massive ancient galaxies. Massive ancient galaxies in an otherwise ordinary background. 6 bright red spots of light were discovered by the James Webb Telescope, and these are no ordinary spots. They are actually some of the earliest and largest galaxies ever found, dating back up to 13.3 billion years. These 6 spots were so red that they must have formed just a few hundred million years after the Big Bang from what scientists previously believed. These structures couldn't even have formed back then. Experts used to think it took a lot longer for the first stars and galaxies to form, but in reality, these ancient galaxies were already massive and bustling with star formation just a few hundred million years after the Big Bang. One of these universe-breaker galaxies is 1 trillion times more massive than our Sun and 10 times the size of the Milky Way. That's huge. In the long run, this discovery has somewhat disturbed everyone because the universe didn't begin like we thought it did, and the dark ages for the universe may not have been so dark after all. Number 2. New finds in exoplanet molecules. For some reason, astronomers have been obsessed with finding an exoplanet with life. Among many candidates, there's K2-18b, which has life. Why is that? For one, they found water vapor in its atmosphere quite recently. James Webb found carbon-bearing molecules like methane and carbon dioxide. So yes, K2-18b may have a hydrogen-rich atmosphere and water ocean, perfect conditions for life. Wait until I tell you that there was even a detection of the compound dimethyl sulfide as well. Guess who produces that on Earth? Just living organisms. I'm sure you're smart enough to connect the dots here. Number 3. Origins of the cosmic web. Astronomers using NASA's James Webb Space Telescope also spotted 10 galaxies arranged like a string just 830 million years after the Big Bang. That's like finding a childhood picture of this universe. But why is it a big deal? Because these galaxies couldn't even have existed back then from our current understanding. Yeah, it looks like it was pretty inaccurate, wasn't it? Also, this structure is about 3 million light-years long and is anchored by a superbright quasar, which is a galaxy with a giant black hole at its center. And guess what? This line of galaxies might grow into a huge cluster of galaxies like the Coma cluster we know in our neighborhood in the universe. Number 4. Early supermassive black holes. You probably know that black holes actually grow in size by consuming passing stars and clouds of gas and dust. Thanks to James Webb, scientists have now captured supermassive black holes working in the early universe, even when they haven't had much time to feast on their surroundings. In fact, it also captured the most distant black hole ever seen in X-rays in a galaxy called UHD-1. The mind-blowing part? UHD-1 is a solid 13.2 billion light-years from Earth, meaning we're watching the black hole as it existed just 470 million years after the Big Bang. This black hole has an estimated mass between 10 million and 100 million times the mass of the Sun, which is downright unbelievable when you consider that it's comparable to the total mass of all the stars in its host galaxy. Number 5. Head Nebula. This nebula is also known as Barnard 33 and is about 1,300 light-years away. All thanks to the instruments on the Webb telescope, astronomers have been able to see the small-scale structures of the illuminated edge of the Head for the very first time. It formed from a collapsing interstellar cloud and gets its glow from being illuminated by a nearby hot star. The gas clouds around the Head have mostly dispersed, but the iconic pillar shape is made of dense material that's hanging tough. Astronomers suspect that the Head has around 5 million years left before it starts to fade away. Now, astronomers can track how dust particles are being swept away from the cloud as they're evaporated by UV light and then create some really complicated patterns. Number 6. The dust left by a supernova. Then there's Copia A, the aftermath of a star explosion 11,000 light-years away, which happened around 3,140 years ago in the Copia constellation. We can still see its remains today. Astronomers are particularly transfixed by the warm dust, which plays a huge role in forming planets and life. Most of this kind of dust is believed to come from the heavy elements thrown out by supernovae. Because of James Webb, we can now see the tiny fragments of this debris made up of sulfur, oxygen, argon, and neon, all glowing in beautiful orange and light pink hues. The dark gaps you see in the image are caused by those tiny fragments piercing through the gas, leaving a cosmic trail of bullet holes. As if that's not amazing enough, we can even see light echoes where the original light of the supernova gets absorbed and reprocessed as infrared light by the space stuff around it. Number 7. A star-forming region in the Serpens Nebula. Thousands of miles away, there's the Serpens Nebula, which is about 1,300 light-years from Earth. This area, which covers about 16 trillion miles by 11 trillion miles, is where many young stars are taking their first breaths. NASA's James Webb Space Telescope found many unusual things in this nebula. All thanks to it, they found aligned protostellar outflows, basically jets of gas expelled by newborn stars interacting with the surrounding gas and dust. These outflows are all aligned in the same direction, which has never been seen before. Not to mention, it also brought forward the Bat Shadow, a planet-forming disk that looks like it's flapping. Impressive, isn't it? Number 8. Unseen features in the Milky Way's heart. Not just that, we're getting a lot more information about our galaxy's dense center, all thanks to the James Webb Space Telescope. The telescope's near-infrared camera recently captured the most detailed image of the Sagittarius A* region, which is around 300 light-years from the Milky Way's central supermassive black hole. In this image, we can see like 500,000 stars, so it's no surprise that some truly mysterious structures have left astronomers scratching their heads. I'm talking about some needle-like structures in ionized hydrogen that seem to defy all known patterns and are much bigger than the scientific community initially thought them to be. And that's not all. A cluster of protostars, stars that are still in the process of forming and gaining mass, was also spotted. Number 9. Jumbo planets. If you're into space, I'm sure you've heard of jumbo. No, not the sandwich. I'm talking about Jupiter-mass binary objects. There are these wild, free-floating planetary mass binary systems in the Orion Nebula, about 1,350 light-years away from us. James Webb found around 40 of these jumbos, and they're like nothing we've ever seen before. Each one has two parts, kind of like a double-planet situation, with masses ranging from 0.6 to 14 times that of Jupiter. They're not tied to any stars. They're just out there on their own. Astronomers used a super-powerful telescope called the Carl G. Jansky Very Large Array to pick up radio waves coming from one of these jumbo systems called Jumbo 24. The radio signals are steady and come from both parts of the binary, and it's honestly quite shocking because these jumbos shouldn't be able to form or stay together as binary systems. Number 10. Analyzing star formation in depth. Scientists have always been curious about star formation, but stars form in dense clouds of gas and dust, right? Well, usually, dust blocks most of the visible light, so we can't see much. But that's where James Webb comes in. Its infrared radiation cuts through that dust and lets us see into all the never-before-seen details. Particularly speaking, there's the Rucci complex, which is only 390 light-years away from us. The telescope captured a frozen-in-time explosion featuring around 50 young stars, many of them about the same mass as our Sun. If it wasn't for James Webb, you'd be as good as seeing a black image. But what blows my mind the most is that the telescope's images have also captured dozens of young low-mass stars along with the high-speed streams of gas and particles they emit, lighting up surrounding clouds of molecular hydrogen. Number 11. Circles of the Ring Nebula. Then there's the Ring Nebula, also known as M57 in the Lyra constellation. We all know it's one of the coolest planetary nebulae out there, and it's not too far from us, only about 2,500 light-years away. But the James Webb Telescope has truly blown everyone's minds by revealing some awesome details about this nebula. The ring itself is made up of about 20,000 clumps of molecular hydrogen, and the inner region is filled with superhot gas. The main shell has this thin ring of carbon-based molecules called polycyclic aromatic hydrocarbons. That's a mouthful, but it just means that there's a ring of enhanced emission from these molecules in there. What sets M57 apart in the images are these 10 concentric arcs beyond the main ring. Astronomers think these arcs were formed near the end of the nebula's lifespan when an aging star shed its outer layers. Number 12. Unusual star formation. Star formation in the Orion Nebula has taken a turn for the unexpected, and James Webb's infrared vision is revealing new details. The nebula's emission lines, which show the density of ionized gases, have exposed some fascinating stuff. One of the nebula's structures, known as the Keyhole Nebula, has been revealed as a giant stellar nursery with a chaotic birth of stars. These newborn stars appear to be developing in a way that's quite unlike what scientists previously understood, suggesting that the Orion Nebula's star formation is more complex than we thought. The Keyhole Nebula also has this cool clump of material where a lot of these stars are forming. This whole discovery might change our understanding of star formation processes across the universe. Number 13. Evolution of star clusters. Star clusters are awesome, right? But their formation and evolution are still not fully understood. And now, James Webb is shedding light on it. In the case of NGC 346, a young star cluster in the Small Magellanic Cloud, James Webb has discovered something super intriguing. The cluster's young stars are at different stages of formation, and its massive stars are changing the surrounding gas and dust through intense winds and radiation. Scientists are now observing the early stages of star formation with unprecedented clarity. The images reveal the interplay between the stars and the nebulae around them, offering a new perspective on how star clusters evolve and interact with their environments. Number 14. Serpens constellation's strange objects. Astronomers have also been investigating the Serpens constellation, where they found some really strange and unexpected objects. Among them is a type of object that seems to challenge our current understanding of cosmic formations. These objects are unlike anything we've seen before, and their discovery is prompting astronomers to reconsider their theories about the formation and evolution of stars and planetary systems. The Serpens constellation continues to surprise scientists with its mysterious and intriguing cosmic phenomena.